afternoon and welcome to East Coast Sailing. I'm Rob and we're on the River Blackwater today. We're going to be testing the Tohatsu 6 horsepower sail drive outboard to see if it will push 5.5 tons of sailboat. So it's pretty strong easterly winds, very cold. It's about 4 degrees today. Last week it was about 29 degrees when I was fitting the outboard bracket. So let's see if this engine is useful, or have I just drilled 4 holes in my boat for absolutely no reason? Let's find out.
If you're new to sailing, you're probably wondering, why does a sailboat even need an engine? Well, this footage was taken at low tide and shows just how narrow the approach is. It's very easy to stray from the deepest part of the channel, and you can see from all the lines that are carved in the mud how many boats have ran aground. It would be impossible for a large sailboat to be able to tack and make any headway efficiently in a narrow channel like this without getting stuck on the mud. And this is why sailboats need engines. You'd never believe this footage was taken 6 hours after a high water. So we're inside the engine compartment and we can see the boat's powered by this 29 horsepower Yanmar Diesel engine. Now this engine's got 3 cylinders and will comfortably push the boat along at 7 knots. It uses about 4 litres of diesel per hour at 2,500 revs. So this engine is actually a 1.266 litre capacity, so it's actually 10 times more than the outboard we're going to test today. So what would happen if all these subsystems went wrong and the engine stopped running? The emergency engine we're testing today is a 6 horsepower Tohatsu engine. It's 123cc, single cylinder, and the model is MFS6D-SL sail drive. The year is 2022, it's long shaft and uses 2 litres of petrol per hour. So what are the differences of a sail drive outboard compared to a normal outboard? Basically you get a charging port that can charge a battery 5 amps per hour, and also the main difference is due to the propeller. The image on the left shows the sail drive propeller, and you can see that it has much bigger blades on, offering up much larger surface area to get more bite. The pitch on the blades is much shallower. It's like riding a bike in a low gear. For every 1 revolution the normal propeller travels compared to the sail drive will travel a shorter distance. And it will also use more fuel, however it will be able to push a bigger mass in the water. The boat weighs 5,500 kilos, and we also have other weight on board such as people, fuel and water, which is another 500 kilograms. So the total weight of the boat is 6,000 kilograms or 6 tons. That's the equivalent weight of 4 average family vehicles in the UK. Here's a quick overview of the remote engine setup. So we have a 10 litre remote fuel tank that takes petrol. We have the fuel line going down to the Tohatsu 6 horsepower sail drive engine. We also have the telescopic tiller handle extender, and I've also lanyarded the engine onto the back of the boat just in case it comes off the mounting bracket.
So I've currently got the auto tiller engaged, and we're on a course of 253 degrees. I've got the engine on about 20% power. So what we're going to do is do one run in one direction. I'll slowly build up the power, and then as soon as we reach the maximum speed, we'll turn around 180 degrees, and then we'll do a run in the opposite direction to make sure the run is fair, because we've currently got a head-on wind and we're running with a bit of tide, so we'll be going with winds the other way and against tides. So let's see how this outperforms. So the engine is currently on full speed now, and you can see that we're doing 4.9 knots over ground. We're going into a head-on wind as well, which is pretty blustery, it's about 20 knots. So the engine is more than adequate to get us going in case of emergency. So what we're going to do now is turn around 180 degrees, do the same run, and we'll see what our maximum speed is, and we'll average both of them. So I've now set the auto tiller to 73 degrees, so we're 180 degrees the opposite direction. Currently got the engine on 20% power, and now we're going to put it on full and see how fast we can go.
We're currently going against the tide with a slight headwind. The engine's punching through the waves at full power. We're currently doing 4.1 knots, which is speed over ground. Look how straight the wake is behind the boat, it just shows how accurate the auto tiller steers. This iconic boat is called Ross's Revenge. It's Radio Caroline's pirate radio station that used to operate offshore. It's 71 metres long and 980 tonnes.
So we currently got Radio Caroline behind us. We're just going to head back now, but we're really happy with how the engine's performed today. It seems to push the boat at about 4.5 knots consistently, hardly uses any fuel. Definitely get us this out of a spot of bother if the main engine ever failed. So I've downloaded a noise meter onto my mobile phone and we're going to take some background readings. So the engine's currently on tick over, reading about 60 decibels, quite low. So let's see what it goes up to when we have this engine at full speed. So I'm getting pretty consistent readings at about 85 to 90 decibels, so it's quite noisy.
To put that into perspective, 85 decibels is nearly the same sound level emitted from a hairdryer or a truck. As we headed back, I was lucky enough to spot a porpoise swimming alongside the boat for a couple of minutes.
Is the engine good?
I think Hugo was trying to say he approved of the engine and thought it was very good. He said it pushed the boat along at 4.5 knots. So we're in the heart of the boat.